soil can hold some.
So
Well, Norm, I don't have all yours back, but I got 5 of the 7, I think, or 8. Anyway, we can go over. I'll go over those.
samples.
You sent in 8.
No, I sent in 9.
9. Okay. I'll let me look here. Let me see what I got. I got. Da, da, da. One, 2, 3, 4, 5, 6, 7, 8. Yeah, 9. So I got 5 of the 9, and the other B crop. But we can go over those, and when the B crops all get finished, I'll send them over. I'll send these over to you as well. So let me share my screen, and we'll launch out on this. Can you see my screen there?
That's coming. There you go. Yeah.
So I'll tell you guys what I've done with BTI. We've developed a portal. The B crop portal is a nightmare. I'll just tell you that. You probably figured that out. It's almost impossible to see the samples and all that through that. Plus, they don't do the completes like I do. So we've used them as a service to be able to get the data sets that we want to look at to build our report. But I'll go over all of those here and show them to you. But so what we do is we'll do 3 reports, 3 different analysis on each sample to give us a good data set that kind of gives us a total story of soil health. And then it kind of gives us better directives on what we can do to improve it, and then monitor that. That's why we developed this report. So we do a total nutrient. So I'm just going to look at this first field, this HED 465. Is that good enough to start off with?
Yeah. What's the field ID?
HED 465.
Okay.
Try to get this thing out of the way so I can open it up.
Okay, this was fall strip tilled and had over 80 pounds of humic put in the strip. And that was all that was put in the strip. It's been a really good farm. 253 10-year average on corn, over 70 bushel on 10-year average on beans, corn bean rotation, systematically tiled. Probably my best farm.
Okay, that's good to know. So as you know, what I like to look
strips.
at, what I really want to see is, are we really seriously, do we have a nutritional deficiency, or do we have other, problems affecting nutrients that are being digested and taken up. And so I like this total nutrient because it gives you pounds per acre of these nutrients here. That's what this center value is in the middle. And this is a top 0 to 7 inch sample.
Yes.
And then it shows you the equivalent fertilizer in value if you were to have to replace that nutrient on the right. So that's what this total nutrient does. So in the case of nitrogen, you see you have 2,500 pounds. That's roughly 5,400 pounds of urea. So that's what Lance developed this on the right, just to kind of show you that I rarely ever see a deficiency in nutrients. What I see is a substantial blockage with the soluble nutrients. And so that's why we want to look at the second report, which is this Haney test. And the Haney test is the reason I wanted to develop our report. Is a really complicated report. Have you ever dove in deep into these and looked at them?
Well, no, and I watched the podcast that Joe sent out this week of Lance explaining all this. Of course, I felt like I was drinking from a fire hydrant. My question on that was, should I had requested Lance to give me recommendations so I would have more information, or I just thought the recommendations were coming from you?
They will.
So I didn't request them.
Call. Yeah.
So in the future, should I request them just so I have that data, or I just don't worry about it?
You can just I can do that. He's building a tool. Lance is getting to the point now to where he's getting so many of these reports, he doesn't have a lot of time go over them. Now he is doing, you'll see they'll have recommendations on the report, and you can ask for those, and he'll put them in here. But these are all generated through a formulation. You'll see why I developed the report I did in a minute. It makes it very clear, because this report, just really two things you got to think about though, or three. He uses this extraction called a H3A right here. And so what this is it's three organic acids that more closely resemble a corn and a soybean root exudate, meaning that the way nutrients are moved is through this digestive system. Works just like our gut, right? We have a gallbladder and a pancreas, and we do the same thing. We're digesting nutrients. It's the same thing the soil does. And so this H3A extraction is what they use to extract all the nutrients. So you see H3A here on nitrogen, H3A on phosphorus, H3A on all the other nutrients, and then he'll also use water, and he uses water on carbon and nitrogen. And so he's got water here on nitrogen, and then he does it here on this carbon piece. And then they combine that. So this whole top piece, 1, 2, 3, 4, 5, 6, 7, 8, 9 different indexes here are all accumulated to give you a total nitrogen number in the form of available nitrogen by using both of those extractions. He does only H3A on phosphorus and only H3A on these other nutrients. But it's using the same extraction for everything, because that's the environment the plant's in. Conventional sampling uses multiple different extractions usually to give you an assumed available nutrient level. In my opinion, that's faulty, because we want to look at what's available there, right, on your farm. The other ones are based on an assumption using a lot stronger acid to say this is what's available over the lifetime of that plant. And what I like to say is that we want to see what's available today. As of this date, April 10th, you had 30 pounds of nitrogen, almost 31 pounds of available nitrogen, meaning that that's there now. Similar level of P, and your potassium, what I like to do is double that parts per million, which will give you pounds per acre in potassium. Those are the NPK numbers, and then we'll do the same with all these other minors if you want to dive into that, because he gives us these numbers in parts per million. Where up here it's pounds per acre. And I want to show on my report, I think you'd be more interested in pounds per acre, because that's what you're putting out. So
Yes.
Parts per million piece is a little bit complicated. And then what Rick did is he developed this soil health calculation, and that's another very important piece, because what we're looking at here is he'll take a piece of the soil sample, put it in a beaker, add water, a known amount, and then measure the amount of carbon dioxide that's released over 24 hours. And what that does is this is a very first approach to really looking at the life of the soil by looking at the respiration. And that soil respiration gives us a calculation where we can actually measure the amount of organic microbial active carbon. And so that's what this is. This respiration numbers in parts per million. And we have a range now. We know that if that's releasing a lot of carbon dioxide, then we know we have a lot of biology there. If it's releasing low amounts of carbon dioxide, we know that we have a challenge in getting higher levels of microbial colonies in the soil. So that's a big important index to watch and measure, and it changes. You can get this to change very rapidly, and that's living off the organic carbon. The organisms are not the total carbon, and when we're looking at total carbon, I'll show you that in a minute. And then or the organic matter. Organic matter is here, 2%. There's a difference between organic matter and organic carbon. I like to look at organic carbon. This is in parts per million. I put it in my report in pounds per acre. There's a calculation we can do to give us pounds per acre. And then when we measure the amount of carbon dioxide coming off of that organic carbon, it gives us what we call a microbial active carbon, which is a percentage of that organic carbon that's food for organisms. This is the reason why Monty's has liquid carbon products and other forms of carbon, because the whole idea behind that is we can get better response from the microbes if they have food sources that are available, that are immediately available. Soil biology doesn't feed very rapidly or very quickly on soil organic matter. The idea that soil organic matter was the home for biology is true, but it's the difference between a carbohydrate in the form of a carrot or a piece of broccoli and a carbohydrate in the form of a Hershey candy bar. We want to be able to get more available active carbon in the form of sugar to be able to feed biology. That's the whole idea behind that, is to get these immediately available carbohydrates to where we can start feeding the biology to a point to where they can actually begin to multiply and grow and develop the soil health calculation. And that's what this SHC is. So the more of this you have, the better. That's what I'm going to show in my report. Then what they did, then what Rick did is he developed this calculation in Lance to show you the traditional nitrogen level that you would have if you took a soil sample and sent it to Great Lakes or Midwest or Waypoint or one of those labs, waters, compared to what this test shows you, which is a 30 pound. So it's almost a 20 pound per acre difference, meaning that we're really in the conventional model, what we've been doing in fertilizer is adding way more nitrogen than we need, relating to what we're going to call that as efficiency calculation. The higher you get a soil health calculation, the better response you get with efficient use of fertilizers. So does that make sense?
Yes.
I'm not trying to take any thunder from Lance, but this is the way this report is designed to work. But in my opinion, it's a complicated report. It always has been. And I told Lance, I said, we're going to build our own and make it easier to read. And then the third piece is this genomics test. And the reason that we take the same soil sample and run a genomics test. This first page, and did you get these? Did they send these to you?
Yes.
Okay.
Yes, I got it.
What I want to really look at is some of the things that are causing that. When we look at that respiration number on the Haney test, I want to know what are those organisms that are respiring and producing carbon dioxide, and what is it that we can look at to see what's low, what's functional, what's working. Are we digesting nutrients? Are we building carbon? This kind of stuff. And that's what this report is. So on the second page, at first was just a summary. It gives you a highlight of the whole report. Second page
Everything
gives
looked
you.
pretty bad.
I'm sorry.
It looked like everything looked pretty bad.
No, it's not. I don't like to use the word bad. These are potentially things we can do to improve, and I'll show you why they're effective in a second. This is not bad here. I see fungi to bacteria ratios that are really out of balance, and in a couple of your samples, we can show you that. But the whole reason that respiration is such an important piece of the soil health is because of the fungi populations that we have out there. What we've done in conventional farming is we've really inhibited the benefit of recycling nutrients. And the way nature recycles nutrients, just think about a native forest, is through fungi. That dead plant falls in the woods, the fungi attack it, you begin to start seeing mushrooms growing on that dead tree, and before you know it, it's completely decomposed, and the nutrients that were trapped in that previous life of that plant in the form of carbohydrates, cellulose, other carbon sources are released and go back into the soil and provide nutrients through bacteria digesting these nutrients to the next generation. What we've done in cropping systems today is we've inhibited that natural process of recycling nutrients. And so we add nutrients in the form of fertilizers, which cause us to have a dysfunction with the fungi working. So that's why BTI have these inoculants. We want to come back in and, because of I would say, and I'm a guilty I'm a guilty person of this because of our misunderstanding of how soils are actually built and how we recycle nutrients. We've caused us, modern farming has been the major cause of all these stress management inputs. We have to put fungicides out, we have to put insecticides out, we treat the seed, we do all these things because of we've inhibited the natural process of recycling nutrients and digesting nutrients. And so that's why I want to really look at this report. I want to know what the total species are. This isn't a population story. This is just what the different species are that we understand, we recognize. There's like in the database, there's like 27 million species. We know what they do, what their functions are. And out of this soil sample, we got how many of those that we understand when we're just beginning to just crack the surface of this. We don't even, there's much more in this than what we see. Out of this 411, these are ones we recognize and understand what they do. So I like to see that number up to around 600 or 700, but meaning that the soil's working. It's not completely non-working, not functional, but we got 411 species, and then the rest of the report is based on that 411. What are those 411 species that we understand? What are they doing? And that's what this report's about. We break it down into both fungi and bacteria. So it gives you a bacteria number here of 1 billion, for instance, and 1 million fungi. And that's what this ratio gives us, 1 to 178. This ratio here is the living fungi that grow on the plant that are the beginning. What they do is the arbuscular mycorrhiza function inoculates the roots. That's what our Prime Pro product is. So you can begin to start getting these organisms growing on the plant to start the channels that we call a pathway. So the fungi grow on the living root. They put out mycelium in the soil. Their function is to work to feed carbohydrates through these channels to the soil bacteria, which need sugar from the plant to digest nutrients. And that's what this ratio is here, arbuscular ectomycorrhiza. The ectomycorrhiza function, these are organisms that actually live on the exterior of the root that protect it against the environment. And so what we've done in cropping systems now is we treat the seed with fungicides and insecticides, which really kind of inhibit the function of this natural process of getting that seed acclimated to the environment. So usually what we have is we start the season off planting seeds in environments that are a little bit hard to get established right. So we end up putting a lot of, which I like that. I think it's just the way to go. We end up putting good carbon sources around that root, around that seed early, so we can begin to start getting that function to working better. What we need to do, though, I think in most systems, because these majority of the reports I see don't have arbuscular mycorrhiza very much in them, is inoculate with mycorrhiza fungi. And so that's what our Prime Pro products are.
We have Prime Pro products on everything we've planted so far.
Very good. Great.
Corn and beans.
Good. That's an excellent start, because you'll begin to start seeing the effect of that with the plant getting into the environment. And then that's how they begin to start digesting nutrients, is through those organisms. This piece is a valuable piece because it tells us an important story, and I'll show you that with some of your other reports. I see consistently all the time, and I've done in the last 3 years probably 4,000 samples or more. Pythium, Aspergillus, Fusarium, and red root rot in corn. I'm almost always seeing these four. Now this isn't bad. These are very low traces we saw in this sample. But what I like about this test is now we can see potential infection, and do we have the ingredients in the soil profile to protect that plant from this infection potential, these fungal infections. And that comes in the form of these biocontrol agents. So our Defend Pro product is that. That's what it is. These are endophytic organisms that naturally will help protect the plant from these pathogen infections. And there's a long story here that we're beginning to discover in agriculture that is really alarming. Norm, it's just really alarming to think about. And I can show you this here, that this report came out in 2018, is that glyphosate and glyphosate resistant soybeans and other crops are the main cause of those four pathogens. So what we do is we end up killing the functionality of our beneficial organisms. That's what this report, I can send this to you if you want to take the time to read this.
Please do.
But what we found is that the germination and growth of Pythium was significantly enhanced with crops that have been Roundup treated. And I've seen that now in enough of these reports to tell you that there's probably some validity to that, is that these herbicides are causing a major decline in our beneficial fungi in the soil. Now, I'm not saying don't use herbicides. I'm just saying that our product that we have, that we developed to add more of these colonies back, is to innovate. Is if we're going to use glyphosate, we need to use innovate. That's my new slogan, because we want to build keep these fungi and defend from, keep these colonies up there, so we can keep these guys, Pythium specifically, at bay. And I got a long story about that. We raise horses here, me and my wife, or my daughter's, and she is too. We sell these barrel racing horses, but we had a mare die this winter, and we did an autopsy on it. Now we buy hay from a local guy here that really loves to talk about his Bermuda grass hay and how it's weed free. So he'll use glyphosate in the winter to kill all the cool season grasses, and then he uses Grazon and other herbicides to keep the weeds out. We call them broadleaf weeds in the sense up here, and we get a lot of annual fescue or perennial fescue. But I tested, him and I have been talking, and I tested his soils, and the Pythium was through the roof. I mean, unreal. And high risk levels. And so I told him, I said, I think we need to change your program. And he did. But we had an autopsy done on his horse, and guess what we found? It was the main cause of this horse had I forget what it's called when it gets in your brain, encephalitis, or one of those diseases that cause decline in the horse. The number one fungi they found in this horse's spinal column and in brain was Pythium. So we're beginning to see that the effects of what this pathogen's doing is a direct result of what we've been applying to the soil. Now, I'm not out here saying don't use herbicides. We've got to use them. I'm just saying that the side effects are going to cause us problems because we've affected our soil quality to the point to where we've made an environment where these pathogens become dominant. And I see that all the time in these tests. I mean, I don't know what we can do to really kind of watch it, but be careful of the amount of Roundup we're using is really affecting our soil quality. So that's an important piece. I like this page because it gives me an idea of what, are you going to be susceptible to pathogen potential in the summer once that crop's growing. This piece of the report gives me more insights into the function of how the soil is adapted to helping the plant reduce stress. So we're looking at the plant's ability to produce hormones. We're not measuring the actual hormone in this case. We're measuring the soil biology out of that 411 organisms we saw. Is that going to enhance the plant's ability to produce these particular hormones, auxin, gibberellic, cytokinin, and then the stress adapters, exopolysaccharides, ACC ademinase, what kind of salicylic acid levels, didn't even measure it here, abscisic acid. These are all very low in this report, meaning that we're not going to be able to fix these by adding these inputs. I'll show you in a minute how we can better improve it to get you, and these will improve over time. And the last piece of the report is the nutritional pathway. We're not looking at the nutrient, we're looking at the organisms that actually help build and open up these digestible nutrients. So carbon is challenged in this soil. And it's because you've been farming that ground a long time, probably, and have been, using conventional methods, fertilizers and tillage and practices, herbicides, this type of stuff. And I'm guilty of it too. That's what we've been taught, trained to do. But we're showing here with the genomics test that we need to reverse our practices to be able to get higher levels of carbon. We're not building organic matter. And that's been commonly known in agriculture. We know that over time we end up depleting organic matter with practices. And so they come out with ideas of cover cropping and no-tilling and all this kind of thing, when reality is we probably need to help that plant's environment to where we can get it to create more carbohydrates. Carbohydrates are what build organic matter. So the plant's releasing sugar, feeding the biology in the soil. The biology then builds this carbon through its processes. And that's how we build organic matter. So each of these indexes, there's 1, 2, 3, 4, 5 here, represent different colonies of organisms that do that specific function. So these two on the bottom, these two here, fermentation and methanogenesis, tell me that you don't have a wet soil. You have a very aerobic soil, because that's where that's good. This is meaning you got good oxygen levels and you got fixation. But what we're not doing is we're not building organic matter. And organic matter is built through higher levels of fungi. Fungi produce the environment to break down residue, and residue then builds higher levels of carbon. We build organic matter, and that's represented in the report. At the beginning of it, I was showing it to you. Your nitrogen pathway is good, so that's that seems to be the nutrient we kind of focus on the most in farming, but that's great. The phosphorus and potassium pathway are challenged a little bit, and that's why we have our products Activate and KPHOS. Those are products that are specifically multiple levels of biology that help with these pathways, that are functional to help open up these nutrient pathways. I wish we could do it all with one, but we found out that the different organisms that solubilize cations versus the ones that solubilize anions are a little bit, would say it's like cats and dogs when you put them in the same bucket. They don't work well together, and they do in the soil, but they don't in a container. So that's why we have KPHOS and Activate as two different products, because they have two different functions. And those particular products also solubilize these other nutrients. So Activate's really strong with carbon, nitrogen, sulfur, manganese. And then our KPHOS is really strong with iron and zinc, copper, magnesium. Oh, and Activate's good with calcium too.
This has 10 ounces of Activate 8 IF on it and 16 ounces of KPHOS.
Very good.
On the plan of it.
Very good. And then we can do some more sampling later next after the season and then compare these. So that's this report. And then so what I do is I've taken all three of these and I've developed what I call the SFA report, this report. And the reason I developed this report is a snapshot that you can look at with all of these indexes. See, there's the 411. There's your carbon nitrogen ratio. There's your microbial active carbon that comes off the Haney test. The organic matter, it comes off the Haney test. pH comes off the Haney test. These all come off the Haney test. And I've developed this color code that's red to green to show that we want to get these green if possible. And then you remember on the genomics test, we had the fungi to bacteria ratio.
Yes.
That's what that is. This respiration number is right here. And then from the stress adaptation to hormone production, this came off the genomics test. I just take that index that shows the total score And I want to see that improve. So now you can just take a soil sample with all three of those together in one report and put it in a real quick form to see it, that you can look at it. I developed this so we could look at them close and monitor improvement over time. So, and then on the right, I put the solutions of BTI products. Joe and I have been talking about, how Monty's products would fit in there too, with carbon products that help with these food sources to help these particular indexes. The second page is our nutritional page. Now, I only added carbon, nitrogen, phosphorus, potassium, and calcium. I added zinc and sulfur on the top of the other one, but this one gives us the total nutrients on the left that we saw on your soil sample. This is off the Haney test, the available nutrients. Now that's the organic carbon number. This is the pathway we saw on the genomics test, meaning that we're challenged here. This is what we got to work on. KPhos here, I'm glad you put that down at the rate you did, because this is pathways are limited to being open. Calcium, you don't seem to have a problem with. It looks like you're going to have potentially,
So, like this field particular, it had gypsum in the fall of 23 at 1,000 or 1,500 pounds an acre. I don't remember. And it's always been heavily lime. I mean, last fall we put 750 ton of lime on what we farm.
yeah.
I don't remember what was put on this field, if any. I got wrote down, but yes, it's not like I ignore them.
Right. Well, you're just showing it. It shows good here with the calcium pathway. I want to see all of these like this. Nitrogen's good too. I like to see this number around 60 to 70, meaning that by the time this, the soil's beginning to get microbial carbon levels get up, and that's what I'll show you back on this page. This respiration number and the microbial active carbon number. These two, this one, and this one are all tied together. They're all tied to this fungi to bacteria ratio. It's more fungi help these pathways. So when we see that our respiration number is down in the 20s, we can, with the right kind of microbial carbon in the form of sugar and liquid carbon sources around that root, meaning that we're creating an environment there that's helping solubilize nutrients. So if you get that number up, you'll be able to see these soluble nutrient numbers go up. Because now it's not going to go up to a level that it'll take. I call it nutrients on demand. The plant's not going to eat all the available nutrients there, this 2,800 pounds, and solubilize that. Now, I have seen that. I've seen some cases where phosphorus, particularly if they're using lots of organic inputs in the form of manures, I have seen phosphorus numbers way up into 600-700,000 of soluble phosphorus. And you may only have 900 to 1,000 pounds of unavailable. So phosphorus seems to be one that's more directly affected by solubilizing high levels of available phosphorus in a setting. I believe we'll see that with some of the samples that we get out of guys like Kevin and other farms that have really high success. Usually we'll see a lot of high soluble nutrient levels. But for the most part, the plant's going to only eat what is solubilized through the function, right? This nutritional biological function. So it's just not going to solubilize a bunch and leave it lay there through the winter. The plant's going to utilize it and use it. But we want to get that up, and that's done by getting this function working better. So that's this soil sample. We can kind of go over a little bit more in depth of the others. I wanted to show you one here that I looked at. That
this would have been fall strip tilled. It was It was cleared in woods in 1999, so it's only been farmed 25 years.
Okay.
Why I pulled it.
Well, and we can see the similar microbial respiration number, microbial active carbon, a little better, higher species number. Fungi to bacteria ratio is still more bacteria dominated. Carbon pathway similar, right? So usually what I'll see is in samples that you know, it usually comes back to the practices we're using that affects the story. So you got a 22% pathway opened, but P and K levels are better. Nitrogen similar to what your other one was, and the calcium pathway is great. And if we look at I'm going to look at this was the one I was looking at. So I'm going to look at the genomics test. Whoop. See those two. So was this beans last year?
Yes. 2024 soybeans.
And if you notice our same, that's not bad. I like seeing that. But
Every sample you have was soybeans in 2024 and it was strip
corn,
tilled for corn in 2025.
okay. You see what I'm talking about here with that story about glyphosate? It's just something that I see a lot of. Why are we seeing so much fusarium and pythium? I mean, I see it in a lot of reports. And then so what happens is fusarium, even though it's an organism, these are crop, you know, they've developed these reports where they're crop specific, but that disease will attack corn just like it will, or pythium will, fusarium will, just like it will beans. But the environment, we're creating environments for these infections to really thrive in. So I'm really beginning to see that in a lot of reports. It just seems to be common. And Norm, I'm a little bit younger than you, but I remember when Roundup Ready technology started, which was in the mid '90s. And we grew up on a farm, and I was thinking there'll never be a day when we'll use Roundup Ready beans. And at the time, my professor that I was my advisor in Oklahoma State was telling me that, oh yeah, there'll be a day when probably over 90% of the beans planted will be Roundup Ready. And I never dreamed that would happen back then. And I'm seeing it now. And the majority of the pathogens I see in farmland are these 2 or 3 different pathogens. So
They always told us when glyphosate hit the ground, it was benign.
I know.
But they,
Yeah.
I mean, some of the green orange that they talk about happens in Florida and California and Mexico. They say it's because you spray Roundup around the trees for weed control, and it chelates the micronutrients in the soil so they aren't available for the plant, and that's why you get the green orange.
That's right. And and another thing I'm seeing, very similar. You remember back when I was a boy, rust was common on soybeans. We just knew we were going to have rust. And once we came out with that glyphosate tolerant bean, I never see rust on beans anymore. So I know that molecule does affect particular fungi. So I'm not saying that's the problem. I'm just saying that it seems to be a really if you're Columbo on the old television series, or it looks like I'm smelling something here. I don't know what, but it seems to be a common ailment. And so I saw a couple of these on yours that I wanted to bring to your attention that had pythium and really real high risk levels. So we may be watching for this this summer, because you may have some pythium in these particular fields coming out in the crop. This field is GRM2.
Yeah. And the west part of that is this farm is systematically tiled, has been 8 or 10 years now. We systematically tiled it. It's a very productive farm. Has some of the highest productive soil types that we have on it. but the beans that are planted on the west half of the farm were untreated and had a gallon of humic, gallon of sugar, and the Prime Pro product on it, and they were untreated beans. So with
I
4 inches of
see
rain we
why.
had last week, I'm a little concerned.
I can see from your nutrient pathways why you had success. Look at these pathways. Really good. 73, 82. Phosphorus a little challenge, but you're 81% here. And carbon, you're doing better on this field than most of the others on building carbon. You have 48,000 pounds. I think this was the highest carbon story I saw. In 572.
Ag line 3 years ago, and it had Jimson on it in fall of 23.
Okay. The challenge here is this ratio. So once again, the fungi, have been compromised. So sugar, innovate, and our primers will help, and Defend Pro will help build these fungi back, and keep your sugar and your carbon sources there. Did I send you? I didn't. Did I send you these finished ones?
Think so.
Okay, I think.
So
Okay.
so when I got that, I just saw it as a list. I didn't realize I clicked on that. Can I click on that to see that then? With what you
No,
sent me?
this is developed. We have a dealer network, and eventually, and I'd like to get Monty's to where they can. This is internal. This is my deal.
Okay.
I
do not. I'm gonna say I do not have that.
I'll get these 5 to you, and then there's 4 more coming.
Okay.
But yeah, this is internal, their dashboard. What I do is I have all of my dealers in here that they can all have access to this portal, and they can come in and click on them and collect them. But we haven't got Monty's to that point yet. We're still trying to convince Joe to do it.
Yeah.
You got so much you can only have on your plate at a time.
That's right. But I get them all, so I get to look at all these. So, and it gives me where they at? Are they getting done? So I really give the lab a lot of pressure, right? I'm on them all the time about, come on guys, let's get these done. Cause I can get this first report done. I'll just show you one here. Within 2 days. And I do this as a basic report. I sent these to you, the basics.
You did. I have the basic here.
So the basic is the report with just the total nutrients and the Haney. And this is Lance's skills. This is where I'll be able to develop this report so we can have something fast.
Yeah, I think you sent me 7 of those.
Yeah, I'll get these. I can send you these, but the bottom line is I want to get them to my report, which is this one, which takes all 3 of them in one. This is what I would call a comprehensive soil health survey. I love this report because it basically gives me all the indexes we need to know to help better improve the soil health.
So like the carbon to nitrogen ratio,
Yeah,
it's yellow at 14 point, whatever. I thought the idea was 16-1.
No, the idea according to Lance, let me just show you that, is when we look at the total nutrient levels, he has a carbon nitrogen ratio here. See that?
Yes.
11 to 11.7. From what we've understood, the perfect level is between 9-1 to 12-1. And because what we're looking at here is you see your total nitrogen, in this case, 2772, total carbon's 32,000. That ratio is 11-1.
11-1. Yeah. Okay. I see that.
So on your Haney test, there's also a carbon nitrogen ratio right here. Meaning that between those 2 carbon nitrogen ratios, and it's the same soil sample, using a different extraction, you've got a major difference between carbon nitrogen and available organic carbon and organic nitrogen. compared to the other one, which was 11 to 1. So meaning that what happens normally is that we're challenged in this case to be able to get that. You have more carbon than you have nitrogen, and that gives you a little bit of a challenge when it comes to nitrogen applications. Because what you're doing is when you add nitrogen, you're trying to get the ratio up. We'd like it to be around, like I say, 10 or 12 to 1. You have more carbon than you have more available carbon, you have available nitrogen. So the way nitrogen is released is through these organisms that actually help solubilize it. So you can actually add it in the form of mineral nitrogen, in the form of urea, or anhydrous or ammonia nitrate, or whatever form you put it out there in. It gets tied up. Your nitrogen doesn't become readily available. So I see a lot of samples where I'll have a nitrogen challenge, carbon nitrogen ratio, like I saw in your report. It's a little bit out of whack, a little bit higher in carbon than nitrogen. So the reason I have that as yellow, that means you have a higher carbon than you have available nitrogen.
So by putting humic and sugar with it, does that helps that though?
It does. You get more,
which we do.
You get more soluble in what he would call organic nitrogen. See, conventional farming doesn't measure organic nitrogen in the soil. They'll do it in a manure report, but they won't do it in a soil report.
We're putting sugar and humic in the 2x2x2, and we put sugar and humic in our side dress.
Okay, good. And when you build this microbial active carbon number up, that carbon nitrogen ratio will go down a little bit. That'll get down to around 10 or 11, 12. So I built the ranges to where that kind of gives you a little bit of it's not bad, Norm. I'm not concerned about it in any means. But I've seen some of these, if you just measured the carbon nitrogen ratio of the residue on your soil, it would be 60 to 1, 60 carbon to 1 nitrogen. So the soil is a major function to helping break down those carbon sources and make those available in nutritional inputs, I would call it. The amount of nutrients tied up in that residue is amazingly high. And I'm going to show more of that this next year. We've been doing nutrient digestion, or residue digestion with one of my friends up in Minnesota. And we're seeing some pretty phenomenal data.
And that's what the Phycoterra is supposed to be for, Joe?
Supposed to help, yes. They claim to put it on in the fall for digestion, but I haven't seen a lot of, I don't know that very many people do it, for one thing.
I like to see us use Innovate every time you can run a spray pass of 8 to 10 ounces, just to get those populations of fungi back. So if you're doing a spray pass now in the spring, use Innovate, even though it's not. We're trying to get those organisms there, get them active, get them working. That residue's still there now, even though you planted.
So Al, while we're on that subject of nitrogen, let me ask you a hypothetical. If a lot of these farmers is off in their fungi to bacteria ratio, which most of them are, and they're applying nitrogen and they're using a nitrogen inhibitor, let's just say agrotane, aren't they lowering their efficiency of that nitrogen tremendously, or not?
Yeah, I mean, the control release idea behind nitrogen was there because of leaching. We thought over time that you can get it to be a more slower available form, and they're doing that with different ways to keep it from becoming available so quickly, or leaching so quickly. I mean, that's what happens. It's soluble and ends up not being staying in one spot. I think it runs off. I'm here to say, why don't we? That's why I like this total nutrient. We got 3,000 pounds in this particular case. That's what we need to be focusing on, I think, is how can we get that nitrogen available? This is mostly in the form. This is a total story.
Yeah. So if agrotane kills biology to keep it from converting, and guys are using Pivot Bio that's supposed to have biology in it to, I guess, convert faster. Aren't they like canceling each other out?
I would, yes, I would say so.
Mm.
Yeah. Yeah.
What in the Activate similar to the Pivot Bio, except
Much.
it has more.
We have a totally different concept in Activate. So Activate, I want to show this. Joe, you're going to share this with everybody because I sometimes hesitate to show this report, but I'll show it to you.
Well, I might, but I'll do what you tell me.
Well, let me show you this. It doesn't matter much because
Pivot Bio worked for me until I started using sugar, and then it stopped working for me.
I'll show you something here. So I just sent this to a guy. I'm going to do it that way. Like, uh, see that okay?
Yeah.
So what I want to do is I want to run a genomics test on this, right? I want to see what the species levels are. This is a number of that of
Mm.
known species inactivate, 281 species.
Yeah.
Then I want to know what they do, right? Are these good? Is Activate good for biocontrol? Now I could show you one of these with the PinPro that would show that way up in the 60, 70% for fungicide agents. So this particular product is not designed to be any more than a solubilizer for nitrogen, phosphorus, potassium. We have 8 different solubilizers in it. That's why we call it Activate.
Mm-hmm.
281 species. And this really follows the genomics test idea. You remember where we had plant hormone production and stress adapters and all that in the
Mm-hmm.
genomics test. I want to know out of that 281 species, are there organisms in Activate that have with these specific functions? 16% will help auxin production. That's a big number when you look at 281. It's not designed for these functions. What it's designed to do is solubilize nutrients. So I wish I could get this thing out of the way. I could open this up a little bigger. Let's see if I can.
Hit your plus sign up the top, make the everything look bigger.
I can't get this bar out of the way is why.
Oh.
Maybe this will do it.
You talking about the bar with got our photos in it?
This bar on that has the there we go.
I think if you click on it, you can drag it.
I can do it now.
Bottom.
Okay, it got out of the way.
All right.
Now I can do it. So when we look at the functions of these pathways, I want to know out of the 281 species, what percentage of that 281 is going to make nitrogen available? 82%. See that?
Yeah.
Means that 260 some of those species are helping with the nitrogen cycle. Now, the Pivot Bio product has one species, Klebsiella ammoniae.
Oh yeah.
I'm going to show you. We have 260 doing that.
Yeah.
It's also helping build carbon, 69%. Potassium, it wasn't real strong in phosphorus. Only half the species and activate help solubilize phosphorus and potassium. I showed you the K-phos report. It's going to be up around 80–90% too for P and K. That's why we had those two products. But look here, manganese and sulfur, calcium, and iron. So there's a reason why we call this activate. It helps with all these the solubilizing of these nutrients.
Yeah.
These are the organisms that are in there. They're all named in the population. I'm going to show you one right here. That particular bacteria is what is Pivot Bio.
Mm.
In Activate, we have almost 2 million per gram colony forming units of Klebsiella. So we have the same ingredient that's in Pivot Bio, plus we have 280 others.
Mm.
I don't usually show this, Joe, because a lot of guys, I'm not trying to push it.
Right.
A little bit.
Yeah.
Figured Norm would like to see that. But that's what Activate is. And we've done that with all of our products. That's why we developed them.
Yeah. That's pretty neat.
Yeah. Norm, you have any other questions?
Still drinking from a fire hydrant, but it's the basics that Joe sent with Lance, because I saw that a couple years ago, but then the refresher watching it for 2.5 hours the other night, and then this, I mean, you get these reports and you think, well, shoot, my soil's dead, it's not going to raise anything, I mean, because I didn't put any potash or phosphorus on. The only thing I put is in furrow that Joe sold me on the corn, nothing on the beans. But, my traditional soil tests, I'm not supposed to be putting any phosphorus on, and potash levels are fine because I've spent a lot of years putting, 350 pounds the acre on every year.
Mhm.
Right.
And I just shut it off and took those dollars to spend for sugar, humic, in furrow, and the BTI products.
Huh?
And you can quickly end your cost production pretty quick, so you got to get a return.
Well, my whole goal is that we could see that you've had a conventional. I don't have it. I'm going to show you. I've got something that you'd be surprised how quickly these things will change. I got to find that where I did that at. But our goal here isn't to try to make these add-ons. We want to be able to take your fertilizer budget. We're developing a brand new tool. We're calling. You'll see that this year. We can take this number and then take the potential of what the percentage would be on pounds per acre per ounce. So we know that Activate IF will give you 4 pounds per ounce. So let's just use a number 10. If you use 10 ounces, that's 40 pounds plus 32 is 70 pounds. How much is 70 pounds of I'm talking about 70 units of nitrogen cost you per acre?
$7 a ton is around 50 cents an ounce, or 50 cents a pound.
Yeah.
So you take $35.
I would love to see that $35 go toward a biological input to help overall change this. Because Norm, what we're doing is our salts, and that's why I have these soluble salts up here. The salts and the impact that we're doing with chlorides, with potash, and the impact that we're causing with glyphosate and other glyphosate and other herbicides are what's really affecting this soil health score. So we don't want to just say you got to just switch everything over tomorrow. What we're saying is we want to build a calculator where we can say, don't just think that you have to continue down this path of using all these, I would call them stress management inputs in the form of fungicides, insecticides, fertilizers, and all this stuff. We can slowly but surely change it over to where we're actually building equity in the soil by building healthier conditions, the healthier soil, get better efficiencies, by putting this program together where we can gradually change the direction of what you've been doing to come back to a way to where we're building organic matter, building soil health efficiencies, these type of things. Does that make sense?
Yeah, that's my goal. The
Yeah.
soluble salts I thought would be a higher number with all the potash that I put on over the years.
No, I'm pretty pleased with that. I like to see that in a, if you get up to about,
0.0
I'd say a
something.
0.3, 0.4, then you begin to be, it begins to be a little alarming. I've got some of these I've seen really high, like in Western Kansas and places like that. You'll see those numbers up around 0.7.
Well, rainfall that I have
Yeah.
would be part of it, I would think.
So we call this, I like to, another term for that is electrical conductivity, showing that, high salts are detrimental to growing good crops. Well, this is not bad. This is good. You got some good buffering capacity, buffering in this particular sample. Your pH is right in the where it should be.
So based on what you're seeing
Oh,
here
this
with
is Luke.
norm,
This isn't yours. This is a different report.
Okay.
I'm sorry.
Okay.
okay. But based on what you've already seen with norms, is it characteristic that he will see improvement each year? Or, and
Yes,
is it dependent on the rainfall and the moisture and all that stuff too?
it's not a straight line improvement, but it's a gradual improvement.
All right.
He don't mind me doing this. I'll just show you because Eric always is, let me look at Eric's.
So,
You
so
did, you went past it.
Well, these are
Listen.
new ones that don't have the
Oh.
new totals.
Oh, I got you.
We can show one of these though. This is one he did but these aren't his farms. These are,
Yeah.
um, he's a guy you all know, so I'll show his,
Norm, while he's looking for Eric's, Eric has decided to, I won't say challenge Kevin, but he is pulling a Haney test. I think he told me every month, or maybe even sooner. He's going to chart a path through the season of in connection with Kevin's program. He didn't like what Kevin told him in the last meeting when he wants to cut back on nitrogen, because he has other farmers in the area that are out yielding him because they're using less nitrogen. And he asked Kevin that, and Kevin said, no, you got to keep using all this whatever nitrogen. And he said, well, I'm not going to do it. I mean, that's what he told me. He said, I'm not going to do what Kevin told me. He said, I'm doing my own thing this year. So we might have a new teacher coming on the scene.
well, here's Kevin's. Here's one of Kevin or one of Eric's.
Okay.
And I don't have a previous, but I know he's been using sugars and carbon for a while, right, Joe? 5-6 years, 7.
Oh yeah, yeah.
But I'm not trying to say but here's where we want to get to. This is where we're doing this. Now, Kevin's, Eric's, he's still got some challenges here. We're going to always have challenges, but carbon nitrogen ratio is right there. Microbial active carbon is just really nice. pH is in the good spot. His organic matter, he's went from, he showed me stories of where he started when he was way into higher 2s, lower 3s. He's up to 4 now. His soil health calculation on this particular farm, 32. Respiration is beautiful. I mean, I love seeing that. That means what we have here is a very active, he's going to get really good efficiencies on nutrition. He's still challenged with carbon. So I've been telling him that we got to get these fungi back. But his pathways for nutritional pathways are nice. There's a little bit of a challenge there with potassium. You see the difference, Nora? What I'm trying to say is that it can be done.
So has he been doing it pretty much with sugar and humics, Joe?
Yeah, he joined the group back when we first started, so that was 6 years ago. He's been trying, been doing pretty much Kevin's type of a program, not exactly because he doesn't want to spend all that kind of money like Kevin has, but then he came on board the same time last year you did with the BTI products, and he was like you at first. He lacked understanding on the beet crop tests and everything, and so Al has really opened his eyes. He is out preaching for you, Al,
Yeah.
a lot of these other farmers.
Yeah. And he's still, and he's still got some challenges, but I think he's on the path to really getting efficiencies now. He's still, doing some things that I think he wants to change and get off of some of his dry fertilizer. But he's looking at timing of when he puts products out and that type of stuff.
Yeah.
So, and I got guys I do have enough data on now, like Wassenaar up in Matt Rasmussen and other farmers that have been working with me a while, that we do have these reports over time to show the improvement. And I'll share those as we get the data collected more. Our goal isn't to always have a take it to yield story. That's always nice, but we also want to show that, last year, for instance, last year, for instance, in Minnesota, they really had some bad rain. They had floods like crazy in southern Minnesota. That absolutely destroyed their nitrogen numbers with all that water. And Dusty still was, 220 bushel corn, but what was really cool was to see the difference in his soil health test. And so even though he didn't get the yield he wanted, he was better than the neighbors, right? They all got lower rates, and he still had a better function. We're going to do more this year. He's showing me, he sends me pictures yesterday of beans he planted 4 days ago that are already popping. So it's kind of cool to see the impact that this kind of testing does. That's why I developed this test.
The Prime Pro beans whole field averages last year was 2 bushel better than the treated beans.
Okay.
That was whole field averages. Now you can say they were probably better farms. But we were in such a drought condition. Some farms, we were 3 to 5 inches from the time we planted till the hurricane came through. So we were in that 47 to 51 bushel yield range when we're usually in the low 70 yield range. So, there's so many things factored that we will have some treated beans to Prime Pro comparables towards the end of the planting season. But right now, the first 600 some acres have no seed treatment on them. Just the Prime Pro. Nothing from the seed company.
Cool.
Well, so to go forward from here, I need to try to do some recommendations. So when you get the complete and send me your completed report there, then I'll kind of know what I need because I got some Innovate 8 the other day, and I know I'll need more Defend Pro because what I ordered early, Joe, was supposed to be my fungicide treatment, and I've been putting it in my furrow. So I'm already short there.
Okay.
Yeah.
So I got to, I want to try to get this order together. So we waiting for the last minute.
Okay. Well, I'll work on that over the next few hours and get something to you early in the week. Lost you, Norm.
You still there?
Yeah, there you are.
Okay.
Yeah.
So I say we're wet here now, and we're going to be wet again starting again Monday. So
Okay.
But the inventory I wrote down and trying to come up with
Okay,
some type of an order.
I'll get that over to you, Joe. And I really appreciate you picking that product up there at AIT.
Yeah, thanks, Norm.
That just makes sense. When Luke picked it up, he said there's 5 or 6 guys. You just picked it up, started throwing it on the truck, and he said he had no way of counting, and just figured it was the sheep that he had, and so that's how it was a little differential. But
Well,
I
that
told him
group
before
kind
he left, that he was picking up $51,000 worth of stuff, and each box was valuable because he does not have a grip on cost of things. He has no experience with it.
right.
Smart kid, wonderful kid to be around. He's here. He said to watch when he pulls in. I mean, you couldn't ask for any more. He just a lot to learn.
Yeah.
And is. So, well, the fact I can't get on that portal, just because when you go to Google Chrome, it changes everything else that I have on my computer, and then to change it back, I can go on every other portal that I have, whether it's with my accountants, my commodity broker, my bank, any portal I can get on just fine on Brave. I cannot get on B Crop on Brave. I got to switch to Google Chrome and
all you would do, they don't like to send the PDFs. I don't know why they don't do that. That's what I said. That's why I'm sending them to you, and
well,
I'll get you the reports without the portal.
I'm not complaining about price, but for what you pay, it shouldn't be hard for them to send a PDF.
You're right. I agree with you, Norman. They're all a bunch of kids. They're all like, below 30 years old. They think that everybody ought to have access to this stuff. I don't know why they are so hard to deal with. That's why Country Roads is helping me, because I can't work with those guys at Mile Makers. I've lost you
Read
again.
this and understand this and try and, get the complete report. I'll kind of understand a little bit better about, what your complete report says. And we can go from there.
I got a tutorial I'll send you. Let me show you this. I'll share this real quick. Can you see that?
Yeah.
I put this together. I'll send this to you, Norm. It just shows you what they mean, each of these total species, carbon, nitrogen, why it's important. I mean, I just show you what the ranges should be. It's a real simple little summary.
I've spent the last 26 years as a certified crop advisor, listening to everything that the land grant universities and everybody has been teaching us since the beginning of time. And this is a little bit of a different direction. And that's Joe and Kevin and Terry and the group have been, trying to swing the pendulum back with me. And this, to me, kind of makes it a complete that I can understand.
Yeah.
Or get to that point.
Yeah, I show you that these are unavailable nutrients. These are the pathways, like I just explained, and then what the total soluble nutrients are. So I'll send this to you too, and Joe, I'll send this out as well.
Yeah, copy me on that. That'd be great.
Yeah. Okay, well, I got my homework cut out. I'll get those together, get them over to you.
Okay. Anything else, Norm?
You're muted again.
Purchase for one of the green lightning machines, so I haven't seen it yet. So I'm drinking the Kool-Aid, as they say. So we'll see how that works.
Well, we got Joe, when is that? When is Kevin's field day? What month is that? July?
No, it's generally in August, but
August?
when I was over there the other day, or actually Wednesday, I said to him, I said, hey, we're going to still do the field day in August. And he goes, well, I'm probably going to be in South Africa. And I go, oh no. And I said, well, what about the week before? He goes, well, I'll be over there then. So I think he's going over for 2 weeks or longer. I don't know, but we're going to struggle to find a date now that's going to work, because the further I go into June or July, he goes, well, it ain't even tasseled yet. And then I said, well, let's go to September. He goes, well, I'll probably be harvesting. Gosh. The one thing after another. I don't know what he's going to do yet. So,
Okay. Well, he really put us in there in the circle this year, so this is going to be.
well, I will tell you this, that he went in, or we didn't dig it up while I was there, but he had gone in, I guess, Monday, and he dug up some of the plot, and he said your product and Ficatera both had mycorrhiza starting on the roots, and we're like V2, V1 or 2, and all the rest of them didn't have the mycorrhiza yet. So that's a plus for you.
That's good to hear.
Yeah.
See that? How do you see the mycorrhiza on the roots?
It's like a fuzz.
Let me show you.
Young, and that young of a plant, it looks like a little fuzz, whitish fuzz. But then the bigger it gets, you'll see almost like a.
Let me send this
strain
to my email, and I'll share it real quick. So this is Dustin just sent me this.
Yeah.
Yesterday.
You remember last year with Wishmeyer had.
Wishmeyer, yeah.
He had all kinds of fuzz and mycorrhiza on little bitty corn.
This is a bean. It's big picture. Let me share this again. See that? Mycorrhiza will be these little, that's what's clinging to all this soil.
Yeah.
Again, this is, he told me this was April 14th is when he planted this.
Yeah.
That's what's holding that soil next to the root is those mycorrhiza.
Okay, yeah. Yeah.
The first trifoliate's hardly even out yet.
Right.
On it.
The nice root mass on there.
Yeah, this is our southern Minnesota farmer up there.
Okay.
And as that plant gets bigger and you pull it out, you'll have a lot more soil clinging to that soil surface. So that's where the magic's done, is right between the root hair and the soil particle.
Yeah.
Sure, I'll have more questions an hour from now.
Anytime.
Or when I get the completed reports, but
I'll get these over to you.
Okay.
It won't take me long to. I don't know where they are on the finishing up on the genomics on the others, but I'll at least get these first ones over. Finished ones.
All righty. Sounds good.
Okay.
All right. Thank you, guys.
All right. Thanks, Joe. Thanks.
Thank you for taking the time. I appreciate it.
Yeah, you're welcome. Glad to do it.
We'll communicate soon.
Okay.
Okay. All right.